Welcome to the AI Engineering Bootcamp Cohort 5. We have a bit of a cool, interesting session today. So for those of you joining us live, it's going to be a lot of fun and you're going to meet some new folks. And you'll also get to see Wiz go slower than he's ever gone before. It should be a blast. You'll also get some optional one-on-one time with a lot of folks. I want to do some quick shout outs though. Big shout out to everybody from cohort 5 that joined us this week in the Build Ship Share session. Let's go. 5 people from the cohort 5. You gotta love that. Mike C is always there as usual. And in case you missed it, Mike C was crushing the love hack all weekend. So shout out to Mike C and crushing it on another hackathon. Mike C's got some really interesting insights into how to win specific prizes at hackathons. I'd encourage you guys to reach out to him and ask him more, or ask him more today if you find yourself in a breakout room with him. One of the things that he said that's important for us to keep in mind in his post when he was talking about this is, there's really nothing like when you're at a hackathon and you get up on stage and you tell everybody, hey, pull out your phones. Hey, click this app. Go to this bit.ly link, bit.ly/dope app. And everybody pulls out their phones, everybody's, and really this is the kind of moment that we want to kind of continue to ramp up towards. We want to start seeing these moments in our lives, the sharing moments that come after the hard work of building and shipping. And this is kind of the theme of the day today. We see amazing stuff happening around the community beyond just the Build, Ship, Share sesh. Alan Tan is a peer supporter, longtime supporter of the community. He's over in the Philippines. He's taking stuff that he sees and he's teaching it in a Filipino language. This is a really easy way to build, ship, and share. I love seeing this. Andrew Potts from our last cohort, he was really into a particular academic, Daniel McClellan's analysis of the Bible. And this was really interesting to use knowledge graphs for, sort of a data domain thing that he got out of class a while ago, just started really getting back on the Build, Ship, Share train. It never stops, guys. You want to learn more about Alan? Check out his transformation of the week last week. We also have some shout outs to do on homework. You guys crushed it on the SDG, homework 7. 21 perfects. Okay, we've got some real heavy hitters still just getting 100 after 100 after 100. Duke, what did you see across the homeworks overall? And what would you like to share with everybody?
Yeah. So overall, I think everyone do a very great job on working through all the concept about the RAG system. And then I love everyone go through all the presentation of everyone. But a quick note that someone said the repo link, but they forgot to give the access. So I couldn't create in the notebook, but I have to follow the video presentation. So just remember that next time. Yeah. Overall, this is a great job, everyone.
Nice. Thank you, Duke. Yeah, remember to give your graders access, especially as we get into the midterm this week and we start to get into the last minute submissions coming next week. Overall, lessons learned. I'd love to see you guys calling out the iteration as we develop our RAG applications, as we do evaluation. It really is a process. And after we build, ship, and share our first prototype is when the process begins. Again, a key theme of the day. How to translate the feedback from these evaluators into concrete pipeline refinements. That's a great question to ask and one that you should keep zooming in on. How to handle hallucinations with SDG, zooming in on that. What do you mean by handle? And exactly, this is where we really have to specify our use case, understand Langsmith tracing better, how large a data set should be. That's also a great question. And again, like so many great questions, the answer is always, it depends. And you must go down deeper into the use case. You guys are crushing it, sharing. We're seeing folks sharing out in public like never before. Ashwin, of course, Kenny, the classics getting after it. We've got Krishanu and Lewis continuing to get after it. And oh, look at this. Jacob, my man, who's running the grading for all of us. He's out there getting after it. And it's been tough for him too. It's tough for all of us, guys. So Coming up this week, join us tomorrow to talk about how we reason in latent space. Last time we talked about reasoning, we were doing it in natural language. And there's this interesting hypothesis out there that, well, maybe we can actually do it directly while we're still in embedding space. Check it out tomorrow to talk more about that. Last time you guys gave us some great feedback, some love that. It's at the edge and understandable. Thanks, Nina. Appreciate that, my dude. And then I love Wiz is going slower through the code. You're going to love it today. He's going to go even, maybe, a little bit slower. Would be super helpful to have multiple notebooks for each session. I'm not sure exactly what this meant, so maybe you can give us some additional context either in Discord or on the feedback today. More clarity on the other parameters' effects on response performance. Yeah, that's a deep, dark rabbit hole of data science there as we talk about hyperparameters generally. Again, the right question. Keep digging in if you're curious about it and it interests you. Go to office hours, talk about it with some peer supporters with some background in it, see if they can get you on the path that's going to work best for you. I'm not sure how to improve it. Okay, thank you. I appreciate you guys being honest about that. Maybe a few images at the beginning of the course and throughout. I like this sort of this idea of like what's the best out there right now, the best tooling out there. It's a very, very hard problem. Lots of people are trying to make these charts all the time. It's always something that's in the backlog. If you can come up with one by the end of the course, maybe it's a starting point. But I hesitate to do that because it's a bit of an audacious thing, and you have to keep it updated constantly. I don't understand why versions are not pinned. Shout out to you, my friend. We will be pinning versions from now on. We know that was probably not the best choice with the notebook last time. Speaking of the notebooks that Wiz produces, he's always trying to balance the amount of detail he goes into versus the amount of detail that's in the notebook. Last time we wanted more written. This time maybe we want less explanation. We're always trying to find that balance, so we seem to be somewhere in the middle. Not sure if we're going to be able to really dial that in all the time for everybody. Also, we know that this was the first time for some of you guys using Colab. We will not do that again, not on this session. That was clearly a failure. So yeah, thanks for noticing and pointing that out. We will either introduce Colab earlier, or we likely are going to drop the fine tuning from cohort 6 and turn it into a prerequisite somehow. And so, it's not going to be an issue directly in that way. We did also see like some of you guys felt really bad about this session. So if you're feeling really bad about last session, it probably has something to do with like your background and it not being aligned with a lot of the training and tuning and loss functions and this and that you really get into when you study classical machine learning and deep learning. And, and I really want to point out like the pre-reading, when you guys are asking for the pre-reading, we are sending out the pre-reading and we do have it available. And so this is some of the most mature written content that we have in the course. So I'm really not sure how else we can push this on you guys, because you're always working on something that's not the session ahead. So again, I go back to pushing this back to the beginning of the course. Please let me know if you have additional feedback or thoughts on that. And then finally, this was a great question, okay? And if the midterm deliverable is an end-to-end prototype, what's left for demo day? And I think this is sort of a big part of today's session. It's a big part of the values at AI Makerspace fundamentally. What you want to think about is we want to get something quick and dirty going with this end-to-end prototype. We want to then align this project towards where we want to go. We want to get it in proper shareable shape. We want to then share it with people. We want to get feedback from them. We want to improve the application, maybe turn it into a real product or a real company, do some real product development, maybe just use it to get your next job, maybe adapt it to something that you're doing at work or something that you can do as a side project as a consultant. But in any case, it's going to get you on the path to building, shipping, and sharing. And that's going to help you achieve your goals, do something amazing, achieve your dreams, and maybe, get exactly where you're trying to go in 2025 and beyond. So, I really also want to point out, like, we haven't even started talking about production yet. And so, like, there's a lot of expansive moreness that we could go into. The prototyping is definitely the hot, more fun, more cool area, and it's something that we should all be good at. But this is, I think, the key is that we want to be good at doing it quickly, and that's the goal this week. And we want to be good at making users feel that wow moment, whether it's our boss, whether we're going into an interview and we just want to whip up a quick prototype, or whether we're actually trying to sell and create a startup ourselves. Okay, shout out to The Wiz and to Arthi. Dope shout outs, love that. And we're into it this week. So this week, we don't really need to talk about industry use cases because we've been talking about them throughout. And we've integrated it better this cohort than ever before. So what we're going to do this week is we're going to do the midterm, and we're going to sort of walk you through end to end exactly what that looks like today. And then on Thursday, we're going to do what we call the AIM games. We're going to put Sarah up on stage. She's going to crush it, and she's going to make sure that we all have a great time. We're also going to go ahead and give you guys some pitch time. Okay, so for those of you that need the practice, that want the practice, which is all of you, you guys are going to have to sign up to get one of the 15 pitch slots where you'll get 3 minutes to pitch, and then we'll give you feedback for 2 minutes, ask you questions, and we'll go on to the next one. And we're going to do it on the big stage in front of everybody, not in a breakout room. So that should be a lot of fun, and hopefully, you know, be a little bit of a reprieve from just the nonstop, constant technical content coming at you. All right, so today, we want to introduce the midterm. Me and Wiz are going to do a full walkthrough example, and we're going to give the Wiz 40 minutes. Okay? It's going to be intense. I don't think we've ever done this before, but Wiz has definitely done 40 minutes before. So let's see if he can keep you guys entertained for 40. Now, also, we're going to give you the option to go and into breakout rooms to do stuff outside of that if you don't want to watch the Wiz for 40 minutes, or if you can use that time better. We want to make sure that's maximally useful for you. And in the second half of class, we're actually going to practice talking about what we're working on while meeting some new people outside of our journey groups. Maybe we'll meet some peer supporters, and maybe we'll have them take their label off their name so you don't even know they are peer supporters. So it should be a fun class, and we're going to go ahead and get into it today with the midterm. Okay, so I want to tell you a little bit about what we know from September 2024. This is a guy in our community who runs stuff at Salesforce, who recently came out with an initiative. You may have heard of it. It's called Agent Force. Let's take a listen to what he has to say. And Sarah, if you could give me a thumbs up on the volume here. One of the things that I'm kind of curious about is how did you guys decide on these job titles exactly?
These are not the official titles, but these are the types of people we're looking for. Number one need are somebody who knows how to build AI systems. Not necessarily somebody who train or fine-tune language models, but people that could systematically scale the hooking up together of various components, as well as to build out things that are missing. Ingestion pipeline, for example. Right? When you want to do chunking and how to decide which vector stores to use, it's good to talk to somebody who knows the difference between Quadrant versus Milvus, right? Somebody at a high level can tell us Quadrant is better because of this, right? That'll be really amazing. That's the number one ask.
Man, so good. So Phil told us about this after he told us about the working job titles that Salesforce was looking at. This was in September, and of course, famously, they said they're not going to hire any more engineers, and also it looks like they're going to do some layoffs while they continue to invest in AI. AI systems engineer is at the top of the list, and you'll notice that our midterm is designed around what we know to be the state of the art in some of the leading companies out there. So we want you to have a broad range and breadth of skills, which is incredibly important in an emerging nascent space. So with that in mind, I'd like to introduce you to search. And Search is our small, engaging research chatbot. So what we're going to do here, we're not going to make it all formal, but imagine that this is like your demo day. I'm going to be a bit meandering here, so we're not going to do it all official, but I'm going to introduce it the way you would introduce it. And then we're going to show you a demo the way you would show a demo. And then we're going to talk about exactly what we want you to do in the midterm before we get into the long form demo. Okay, so let me set the context here. All right, so the CEO and corporate has come down, and with permission of the board, they've said, all right, let's get a crack team together. We need agents, we need RAG, we need ROI. That's what we need. And you have been tapped to really help out because they heard that you were in the AI engineering bootcamp and you had all the skills they need to build, ship, and share something for the big company presentation that's coming up. But you have to figure out what to build and why. You're going around, you're talking to people in the company, and you're realizing they're worried because they don't understand AI. They don't really get how they're supposed to do useful things with it. They hear all these crazy things about it, but it's a very complex topic. And if we zoom out, this problem has been identified as an extremely meta problem by the industry. Understanding very complex topics with many sources is very, very hard. And if we think about one of the questions we can ask when we think, should I use an agent or not, is, do I really need flexibility to be able to efficiently solve the problem? Well, when trying to investigate very complex topics, the answer is yes, which is why we've seen research and summarization and these search and research tasks really at the top of the list when it comes to agents, when it comes to talking to our consulting partners. And the industry has seen that this is not just consulting work, this is product work, right? Deep research came out from Google in December. Find anything you need in a comprehensive, easy to read report. Classic Google. February 2nd, OpenAI comes out. Chad move, they call it deep research. Very unique here. And then this is all about creating that comprehensive report at the level of the research analyst. And since then, I don't know if you guys saw that sick drop on February 4th by AI Makerspace, but there's been Perplexity launched this week. Grok from xAI launched deep search this week. There's been a lot of dope, deep stuff happening, right? And so like, there's all that research stuff, and that is a problem. And yes, that tool exists today. In fact, lots of them exist, and you could probably pick it up off the shelf. But you work for your company and the CEO and corporate, and they don't know about deep research, and they don't care. You need to show your stuff. And so this is a perfectly fine application. The nature of the beast is that the applications, many of them that get built, will instantly become outdated when the models get better and better and better. In fact, if you joined us in the Build, Ship, Share session this week, you may have noticed that that's kind of happening for one of our resident Build, Ship, Sharers in the video domain. Okay, so back to the problem. People are worried at the company because they don't understand. They see these things and they want help understanding how AI is evolving, how it can actually be useful. So let's build something. Let's build something that, is like an agent that uses reasoning to synthesize large amounts of online and complete multi-step research tasks. Something that really saves you hours of time by conducting in-depth research and analysis on your behalf. And let's identify some data that we can start with. Well, we've looked at the blogs online and we like this one. We have an affinity for this one, actually. And just so turns out that we already created some vector stores for this one. So it's a great pick, right? It's a great pick. And so we have our problem, people tripping about AI, our audience, our coworkers. We're not quite sure what questions they're going to ask yet, but we can build a quick prototype and start asking and start getting it in front of them. And our solution, the small, engaging research chatbot. Let's see how it works. Wiz, take it for a spin here real quick before we go into the deets.
Oh yeah, we'll be spinning. Okay, so basically, it works how you would expect. There's a little front end, which is visible now, and we can ask questions. We can say things like, what makes the paper recurrent? Let me use my clipboard here, so I'm less owning you with typing. Scaling up test time. This is the recent paper that says models thinking in their own latent space is real good. So cool or interesting. And you can see we can just send the message off. We're going to wait a little while. We're going to get a full response. Behind the scenes, we have a number of different tools that our model can use. We have a, archive tool. We have a Tavili tool, and then we have our AI RAG tool. You can see we get a pretty solid answer. Loads of tokens, really kind of outlining everything that we need. These are all fairly, they're all correct responses, which is nice. And we can also ask things like, what is up with agents, in 2020, 2024 to 2025. And again, we're going to be able to get a response from our agent, which is going to give us, the details right from our data set using the RAG tool, as well as the Tavili search tool, which is going to mean that we're getting kind of both sources of information, right? So we have diverse definitions. Greg and I know this very well. Code gen's becoming a big thing. New models help agents a lot. Autonomy and gullibility, absolutely true. Evals, super important. We kicked off the year with an evaluation event just for this reason, right? And limited real world implementation. They're still struggling to find their place. So there you go. This is the idea of what a complete application would look like. So when you're all said and done, and we'll go into everything behind the scenes, but this is what that might look like.
All right, thank you, Wiz. And all right, so really what we want to think about is everything you just saw, except the little sidebar on like actual deep research, is the kind of thing you want to present for demo day. Nobody cares about your code behind the scenes. They just care that it works. Okay, we're presenting this to users, we're presenting this to stakeholders. The wrap it in a box is quite important here. It's like a Christmas present, right? We don't want to just put it out under the tree. So when we think about the midterm, there's some simple requirements. We need to have an end-to-end prototype, just like Wiz just showed. It has to be something that people can actually use that aren't you. We want to do some SDG. We want to create that test data set for evaluation. We want to show that we can do something like fine-tune embeddings and improve. So that means actually swap out the embedding model with an open source model. It means actually show the improvement or the, near same evaluation numbers for open source versus closed source, where we get that extra nice little open source blip. And then, we want to assess at the end of the day, like, what should we do from here? Should we go change models? Should we change chunk sizes? Should we change something else? What are we excited about learning and adding to this thing next? What did we learn in the process? And so our final submission is going to be a GitHub repo with all the questions answered. It's going to be a functional app, and it's going to be a fine-tuned embedding model. And importantly, we want you guys to track your hours. This is because, like, you're going to have to get this stuff done in a reasonable amount of time. This is not a research project, although search kind of is, okay? But, like, this is an app, and you got to build it, and it has to work. And if you take forever to build it, no one's ever going to hire you as a consultant or full-time. So we got a great question in the Discord that I really loved. Shout out to Frickster here. Is it just me, or does the midterm look like a 50+ hour project to be completed in a single week? Well, I would say, like, that's up to you. And I did see some stuff in the chat here talking about, scope and all of that. It can be, okay? But, I will tell you, last time when we told people exactly what to do, this is how much time they spent. Okay. And they really didn't like it because we told them exactly what to do. And that makes sense. But they still found it incredibly useful to have gone through the process. You'll have an artifact at the end of this thing. It will be shareable. It will be a GitHub repo. In fact, many of you could probably go ahead and achieve all of your dreams and goals for 2025 with just this repo. And, and maybe that's enough. Okay. But at the same time, what this does, as I talked about earlier, is it gets us in this headspace of this is just a prototype. What are the cool things that we can do to it now? What are the cool production things we might want to add to it? What are the cool features we might want to add based on what our users are telling us? How are we going to optimize the data and the tooling? And should we add multi-agents and should we add advanced retrieval? And should we, look at cool new tools out there or vision language models or whatever the case may be? We have all of the boilerplate code already, as Wiz will walk us through. But I want to just walk through real quick. There's 7 tasks, okay? And there's some preamble, some overview. If you've heard me talk, you don't need to walk through this all. But we want to define the problem and the audience. This is, again, YC 101. It's any accelerator 101. It's any new data science and engineering team 101. What are you working on? Why? Who's it for? We want to propose a solution, and we want to be able to talk about the things that Phil said. Why are you choosing Quadrant? Why are you choosing that specific open source model? These are the details that matter, and you have to be able to have an answer, and your answer can't just be, I'm not sure. It can't just be like, well, that's what I learned at AI Makerspace. You've got to show some leadership here. And this is what we want you to start doing with this midterm, because this is actually what the industry needs. And we know this from talking to hiring partners. They want to hire you if you can do this work. And so identifying the data, sometimes like we just saw with Wiz, it's just the archive tool and the search tool. Maybe that's enough, okay? But you have to wrap the problem around it. You have to find somebody to build it for. You can't just sort of build in a vacuum and just play with tools and get where you're trying to go. It's never worked. It's never worked. Building a quick end-to-end prototype and creating a golden test set, fine-tuning, and then assessing and going. So your final submission will be what we talked about. And I want to be very clear, it must be 5 minutes or less, the Loon video. Otherwise, you will not pass. We're restricting the time limit on this. And then finally, I want you to notice that we also put in here a complete example midterm where I've answered all the questions and described this little story that I just went through for you already, okay? So again, you probably shouldn't even look at this, but you can, right? Because this isn't about, trying to test you academically. It's trying to see if you can do useful things like the industry demands that we all do. And if you really, really want this life of being out on the LLM edge. So that's what the midterm is here to test. It's part of the certification process. I want to be clear that, it's not something everyone must do to keep coming to class, but it is something that I would put forth that you must do to be able to really get where you're trying to go in 2025 if it's in the field of AI engineering. So the breakout room is going to open, okay? But Wiz is going to stay here and the breakouts will be optional. You can go and you can hang out with your journey group, peer supporter, or you can stay and watch Wiz the whole time. He's going to walk you through exactly in one notebook the whole midterm. So I don't expect many people to leave, but if you'd like to leave and go discuss, you can go to one-on-one support, you can go to your journey group, you can go find somebody for help. We're around. We're here to help, whatever you need. Okay, but with that, I want to get out of the way and let Wiz do his thing to go through how to actually build, ship, and share this thing. Task 1 to task 7. Midterm edition, baby. Let's go. Wiz, over to you.
Hey, alrighty. So what we're going to do is we are going to work through a big old notebook. I am not going to be sharing this notebook just to shortcut some of the questions. And I will explain why I'm not going to be sharing the notebook as we move through the notebook, but largely it's due to the fact that you have all of this code already. I will tell you all of the lines of code that I have modified from existing code in the AIM repository, which is a very small percentage of the actual code. And yes, you can refer to the actual walkthrough or the video if you need to. The idea is that we want to start with a kind of a sample project and then work our way up to the final, to do. Now, what you saw in the actual, demo that we just showed was basically the very end product, right? So there's going to be a lot more that goes into that. So there is a big beefy notebook that we're going to work through all together. It's going to be exciting. It's going to be fun. I promise. And okay, let's just jump into it. So first things first, task 1 or 2, Greg's already walked through. Basically, ideate, figure stuff out. What are you solving? All that stuff. This notebook starts from you've figured it out. Okay, so we're starting to build now, right? And you'll notice we have a big old wall of imports or dependencies that we need to install. Everyone loves that. Tons of dependencies. You have to provide some API keys. You notice we're using Cohere, Tvili. We're going to use OpenAI, of course, and then we're going to use LangChain or Langsmith API keys. Easy peasy, lemon squeezy. Then we're going to prepare some data. So the first thing we've used this data before, right? It's the same old data. Nothing's new here. This is just the blog data that we've already been using the whole time. And then we're going to go ahead and we're going to load our data using the data loader from LangChain. Okay, so we've got it all loaded up. And then, so we also have a separate source of data, right? Because we need 2 sources of data. We need the ability to, use this RAG style data. And then we also want to have like an API. And the API is going to be, in this case, Archive and Tvili. So we're going to use 2 separate APIs for this build. You don't have to use 2. You can use just 1. You don't have to use these. You can use whatever makes sense for your use case, right? But we want to have some ability to like look and see current information as it exists on the internet. All right, so now we're going to build a simple agent, and we're going to build this just the way we've done it before. So we're going to load our data again. We're going to have our recursive character text splitter split our data into chunks. Just zoom in a little bit here so it's a little bit bigger. And then we're going to go ahead and we're going to use the OpenAI embeddings. So this is the text embedding 3 small, very classic embedding model. And then we're going to load up our quadrant vector store. Again, this is all stuff that we've already done. We've seen before, not new. It is, instantiating the client, adding the collection, and then we're going to go ahead and set up our LangChain vector store. Then we're going to add all of our documents to that vector store. We're going to set up our retriever. Remember, the retriever is the abstraction through LangChain that allows us to actually get some number of docs. In this case, we're going to get, these 5 top K docs every time that we use the retriever. Then we're going to build our little retrieve node. And then we're going to build our RAG prompt, classic RAG prompt. RAG prompt is basically just, hey, you're helpful, answer the question using the context. If you can't, say you don't know. Easy peasy. Then we're going to use GPT-4o Mini. GPT-4o Mini is a great model because it's super cheap and it does RAG real good. So that's where we're going to use it today. And then we're going to have our generate state. Our generate state is, or generate from state is just going to take our contexts. It's going to format our prompt with them, and then it's going to call this LLM on both the context and the prompt and the question, and boom, we're going to get a response. We're going to create our little state dict. The little state dict is basically just where we can shove stuff so that state exists somewhere. And then we create our sequential state graph, nice and easy. This is all from the RAG notebook, right? This is all from the RAG notebook. No new lines of code here. We can see that it works. However, we're going to add one new line of code. Okay, so we're going to do a new thing, right? This is new thing number 1, which is that we're going to create a function that calls our RAG tool, and then we're going to decorate it with the LangChain tool decorator. So this is going to take this whole graph that we just built, right? And it's going to turn it into a tool that can be called now. There you go. So this is a a new bit of code, but all it's doing, right, is it's just saying, hey, call that graph on this question and then return what you get. There you go. And then we put the tool decorator so that it can be easily slotted in along with the other tools. You also notice that we have this doc string. The doc string is not for us; it's for the LLM. So make sure you write a good prompt here. There you go. Now we're going to assemble our tool belt just like we did in our Intro to LangGraph Agents notebook, except this time we're going to also add this RAG AI RAG tool as an additional tool. And we don't need to do anything past this, right, to make our graph into a tool. This is sufficient. This will now call this tool. That's it. We don't have to format JSON. We don't have to worry about defining a function signature or creating a Pydantic schema. All we have to do is make this function and decorate it with tool. Very, very, very nice. Then we're going to use our big model, let's call it, right? This is like the agent model. We're going to use GPT-4o, not Mini, for that one. The reason we're going to use GPT-4o is that this model is going to have to do a little bit more work. It's going to have to choose which tools to build or to call, when to call them, how to call them. So we're going to go ahead and we're gonna fork over the cache for the GPT-4o as opposed to 4o Mini. But behind the scenes, our RAG tool is still going to use that GPT-4o Mini, right? So it's still going to leverage the fast, cheap model because RAG is easy compared to, figuring out which tools we should call. And then we bind all of our tools to our model, again, straight from the LangGraph notebook. And then we build our actual LangGraph agent, which is going to have the call model node, which we're going to call our agent node, and then the tool node, which we're going to call our action node, as you can see in this graph, set up here. Once again, to build a graph, we start from nothing. We add the agent, we add the action. We set the entry point to be the first node we want to hit. And then we have our conditional edge, which is going to tell us, should we go to action or should we go to agent, right? Or should we be done? Should we finish? Should we go to end? And then we tie the action node to the agent node to say every time we do an action, we should go back to our LLM, nice and easy. And then we compile it, no errors, big money, no whammies. We're going to try this out on a few different questions. Who is the captain of the current Winnipeg Jets? We see that we use the action node, but the action node that we're going to use specifically is going to be the actual tool, which we're going to use the Tvili tool. So we're going to use a web search tool, right? This makes sense. This question has nothing to do with AI and nothing to do with academic papers about machine learning or any of the sciences. Okay, makes sense. For this next one, we're going to have the query search archive for the QLoRa paper, then search each of the authors to find their latest tweets. You can see here that we're going to go ahead and start with archive because we said to. The model is smart enough to know that we should start with archive. And then we're going to secondly use Tvili to do the web search part. We don't have to specify that we should use Tvili because, searching each of the authors is not handled by any of the other tools. Only the Tvili search tool can do that task, and so it is selected. We love to see it. And then finally, we can say things like, what is the current state of AI agents? And then we can see here, boom, we use the AI RAG tool. Who knew? GPT-4o, it can do it. It knows when to use which tool. This is the whole idea. It knows when to use, a tool followed by another tool. The other thing that it can do, which can confuse some people, is it can call multiple tools at once. So say there was not like a sequential, like there was not a dependency on a previous response to call the tool, right? Say we wanted to talk about two things that were unrelated, the state of AI agents and also what's the weather like in California today, right? The agent is going to be able to call both of those tools at the same time. It's going to look in this message list as one tool, but will actually be both tools. The only reason we see this separation here where we use archive, then we use Tvili, is that we have first to find the authors for the QLoRa paper from archive, then we can go ahead and search the author's latest tweets. All right. So and again, we've seen every one of these lines of code with the exception of that one tool definition, right? Which is just a simple Python function with the tool decorator. Thanks, LangGraph, for doing a lot of the work for us. Next thing we're going to do is generate synthetic data to test this system out. And we're going to use exactly the code we've already used from Ragus. We're just going to generate some samples. Easy peasy. You can see all of our samples here. It comes with this context. You'll love to see it. And then we have new code. This new code is the context parser. All this is a lot of code, okay? Don't get me wrong. But all this code does is just dynamically generates context based on which tool was called. There are loads of ways you can do this. You could most easiest or most easily, you could have a whole new way that you set up your LangGraph agent, right? So instead of the way that we've set our LangGraph agent above, we can set it up to care more about passing context from each of the tools. But that would require quite a divergence from the provided code. And so this basically this helper function, all this does is it parses out context from our tools. And then we can go ahead and we can answer the evaluation for each of those using that extracted context. So what this means is that we're going to consider like the web search results as context. We're going to consider the archive paper summary that we retrieve as context. And we're going to retrieve of course, the context from our RAG pipeline as context. The idea here is that each of these tools doesn't really have a context, that we've specifically built into the system, right? So we have to extract it otherwise, but all we have to do is boom, extract it in whatever way you should feel is most epic, and then we can have some context. You can see here that it does the thing. We retrieve contexts, and then we can go ahead and we can add these contexts as our generator, retrieved context, which we're going to be leveraged for, of course, Ragus eval, right? We got to do some Ragus. That's the next thing. So now in our Ragus dataset, we have populated both our our retrieved context as well as our responses. This in addition to our reference context and our reference response is going to mean that we are good to go. The next thing we should do then, of course, now that we've filled out our evaluation data set, is we should evaluate it. So we're going to use our Ragus helper functions to do this. We're going to use GPT-4o as the evaluator. We're going to set this config to be 360, so it times out less. It still times out. Classic, that's okay. Do whatever you have to for the midterm. Ratchet this thing up to 7,200. But the idea is that it's just going to take a little while for some of these responses to complete, and so you'll have to set your timeout appropriately. We're calculating it on the whole slew of Ragus metrics just for funsies, and then we're going to see that we finally come up with this response, which means nothing, right? There's no. It's like, okay, some of these numbers are good, some of these numbers don't look good. We don't know anything other than if we make changes, they should change. So one of the changes we're going to make is we're going to fine-tune an embedding model, right? So that's the next step in the midterm. So that's what we're going to do. We're going to go ahead and again, just rip. All this code is back to just being from a notebook we've done, right? There is no new code here. So if people were wondering, can I use this as a template? Can I, can I leverage this notebook as like a templatized version for my project? The answer to that question is no, but you have all of this code. Save like 2 cells, right? So you've got a template already. You just got to glue it together. Then we're going to start our fine-tuning of embeddings. We have to nest async IO because we're about to abuse the async function. And then we're going to load some data again. And this time we're going to chunk it a little bit differently. We're going to go ahead and we're going to, again, this is from last week, when we talked about fine-tuning embeddings. We're going to set up all of these IDs and everything. Very cool. We're going to do the same thing, get our train test split. Everybody loves a train test split. And then we're going to use GPT-4o Mini to generate some questions for us. The questions are going to be generated based on this prompt template. This prompt template is basically just saying, hey, I'm going to give you some context. You need to generate n questions. They should be in this format so we can parse them out real easy. And it does, because it's a smart model. This is a LCEL classic. All it's doing is making sure that we go from this prompt template that we have set up above to our actual model. There you go. Then we're going to use the async function to generate a bunch of questions. And again, we're using async because it's fast. That's it. That's the only reason we're using async here, because it would take way more time if we didn't. You can see we generate 78 pairs in our training set, 12 and 12 in our validation and evaluation data sets, or test data sets respectively. And then we can go ahead and save them just in case we want to do it later, or we're doing this notebook in multiple steps. And to be clear, we're shoving this into one big notebook because it's it's fun. It's just going through everything we've done. I'd recommend you probably have more than one file that you're working in, right? So do your fine tuning in its own notebook or file, and so on. Then we're going to go ahead and grab our model. We're going to use Arctic embed M. You could use L, you could use S, you could use whatever model you wanted right here, as long as it can be fine-tuned and is compatible with sentence transformers. Then we're going to create a classic data loader. We're going to set our batch size equal to 10. We're going to shove a bunch of examples into our examples list. Then we're going to turn that into a data loader. Remember, the idea of a data loader, we didn't touch on this a lot, but the idea of a data loader in PyTorch is that basically you just slurp out, right? You just slurp out data out of the data loader, whatever you want. So I say, hey, data loader, give me 10 pieces of data. And data loader goes, here's 10 pieces of data. That's all it does. The reason why we care about using a data loader is because, of course, trading is slow. We don't want data loading to be slow, so we use this faster process to make sure we're able to get as much data as faster as possible. Okay, then we're gonna use Matryoshka loss. We got to. This is like table stakes, right? If you're at a company that has 10,000 vectors, no one's gonna care if your vectors are all 768. Okay, no one's gonna be worried about it, right? But if you're at a company that has 10 petabytes of data, right, that you're needing to index, like suddenly those little the extra size adds up extraordinarily quickly, right? It can really break the bank if you're not worried about it. So Matryoshka loss is a extremely important thing to keep in mind and leverage. And when people say things like, how are you gonna, how would you efficiently index this material if we have, say, a billion rows of data, or we have like a billion text files, right? Matryoshka loss is a way that you can sound smart, stand out from the crowd, and still do the best work that you can. The advantage of Matryoshka loss is when you have little subsets of data, right? We can use the full expression, the full representation of that vector. We're not losing anything, which is great. We love it. Okay. Then we're going to just set up our evaluation or evaluator. We're using our information evaluator here, information retrieval evaluator. This is, because that's the task. Can we retrieve information real good or not, right? We need a check mark during training. This is similar to what we talked about when we were talking about GERPO, right? GERPO needs some kind of signal, some kind of idea that's doing a good job or not. This is what we use for this metric. All right, here we go. And then we're going to disable WAND-B, but you could enable it. It's up to you. I'm only disabling it because it's not everybody had a WAND-B API key. I would recommend that you get WAND-B, but it's not like mandatory for the midterm by any stretch of the imagination. All right, then model.fit. This is where the magic happens. We .fit the model. We don't actually fit the model. Someone asked us in office hours. Okay, .fit means .train here. We're not fitting a model in the hyper-specific technical sense. You can blame the library authors for this. A .fit's a holdover from when we actually did fit models. We're training the model during, using backprop, just like you would normally train a model or an LLM. So don't get too excited about .fit. And then, we can see that we train the model, and the model does a train. It goes from being not as good to being good. Good job, model. We're going to go ahead and push that model to the hub. Then we're going to use that model in our pipeline. Now, you notice that this code is not only code we've seen before in the sessions that we've had together. This code is code we've seen before literally in this notebook, right? We're just going to reset up the pipeline that we already set up, except this time we're going to use Hugging Face embeddings, right? So we're going to use our fine-tuned embedding model. This is exactly the same quadrant code we just saw. It's not deja vu. This is really the same thing, right? Then we're going to set our retriever up, classic, and then we're going to set our retrieve adjusted up, because we're also going to add re-rank, just because I like re-rank. Re-rank number 1, so we're going to put it in there. That's why Cohere was at the top of the notebook as well. Basically, this is going to help us. We have even better embeddings. Now we have a re-ranker. We ought to be retrieving good context for a lot of this stuff. That ought to have an impact on some of our RAGis metrics. We'll see. Spoiler alert, does. Then we're going to set up the same RAG prompt we had before. And then we're going to set up the same, we've been through exactly this, right? For our sub-RAG system, we're going to use GPT-4o Mini. We have our generate node. We have our state. We build our simple state graph, which just goes from the retriever to generate, right? It doesn't do anything fancy. There's no decisions. There's no tool calling. It's just a straight shot right through. We test it. We can see that it still looks fine, right? Nothing is broken. This is good. We're going to set that thing up as a tool now, right? So this is a separate tool because we've changed the guts. So we got to set it back up. We're going to set up our same tool belt. And again, this is all, we've just looked at this. We just went through this together in the top of the notebook, right? Call model, beautiful. We set up our new graph. Should continue, right? Again, do we need to do a tool call, or can we just be done? That's a conditional edge. We test using that same parsing solution we had before. And then we're good to just evaluate, right? We've got new retrieved context and new responses. Let's evaluate and see what changed. It's exactly the same evaluation code. And then I wrote a very small metric delta helper function. All this does is tell us how we did. And you can see, I'm going to zoom in real big on this one. You can see that changing our embedding model, right, and changing our process to include re-rank had some impact on some of these metrics, right? Like very small effect, but it had a big impact on faithfulness, right? The response we're generating is much more faithful to the context that we've collected. Wow, great job, model really crushing it. You might think to yourself, well, why is the faithfulness higher, right? Isn't that a generator thing? Well, we have more coherent context chunks that are being retrieved by our RAG system. So what this means is, instead of having, one very related context block and then like 2 others that are kind of or sort of related, we get 3 pretty related context chunks. And this means our faithfulness gets a big old bump. And that's the idea. That's the whole thing. We're going to very quickly look at the actual app, which you do have access to because the app is public, right? And you'll notice that the app.py is just, here's all of the imports from the notebook, and then they've been copy and paste to the top of the file, okay? And then here's all of the code that we just did, but without any of the markdown, exactly, right? And then we shove that into the user session when we have a chat start, and then we call it whenever we get a message. That's it, right? This is 100% copy-paste job from the notebook, right? So when you're prototyping this in the notebook and you need to go to the deployed prototype, it's just a copy-paste job. You can use a formatter in VS Code to handle even sorting the imports. You can just copy and paste them cell by cell. There you go. That's what it is. That's what we did. I know that was a lot. I went on for quite a while here. There you go. That's the midterm. That's how you do it. That's how you wind up with this. It's a lot, guys. Okay, it's a lot, but it's not like it doesn't have to be totally new, right? Like a lot again, all of this stuff there were 3 functions that I needed to produce to have this end-to-end thing glued together, right? The rest is straight up stuff you've already done. I know the midterm's big, right? It spreads across a lot of the topics we've done so far, but you've done all of them. If you've done every homework up till now, you've literally done every part of the midterm already, right? Like from the technical standpoint, to be clear, all the code you've already ran through it, right? You've already seen it. You've already clicked play, whatever, written some. The idea is that this is just gluing all of these disparate parts together into one big end-to-end story. There you go. Okay. Again, we're not going to share this notebook because you already have all of this code. I will share the helper functions because that's novel code. But otherwise, you already have all of it, so there's no real point in sharing it. And you will have access to this app if you get stuck on how do we go from notebook to app. This is another example. There you go. Okay, I've been Wiz. You've been great. We'll go back to Greg.
All right. Okay. So what I want to do now, everybody, is everybody that's with us in the main room here, if you have questions about what Wiz just went through, we'll take those while everybody else is in a different breakout room. If you want to like talk about something that's not related to the notebook or the midterm specifically, I would encourage you to go to one-on-one support. So feel free to raise your hand or throw it in the chat. Let's go ahead and go to, did you get Kenny's already in the chat, Wiz? Somebody check marked it.
Yeah, it was me.
Yeah, okay. So you're good.
Yeah.
Beautiful.
But yes, the actual, like aside from that, you have to build the LangGraph agent, you know, somewhere, right? The actual code to call it with Chainlit is nada. It's very straightforward. Now, I would suggest like maybe we want to add streaming. Maybe we want to add some bells and whistles, right? Maybe we want to add like the output of the of which tools being called when and this kind of thing. You know, but for like quick and dirty, what you need it to be able to do is someone enter a query and then receive a response. And so that's what we focused on.
Okay, beautiful. Then let's go ahead and go to the questions with the hands raised. I think Waleed, you were first. Let's go for it. What you got?
So just wanted to clarify what was the role that Matryoshka loss function was playing? Did you fine tune the retriever model? Okay, and then reuse that in your app?
Yep.
Okay. Just wanted to
Yeah,
clarify.
yeah, and there was
Matryoshka
another
loss.
question. Yeah, there was another question on Matryoshka loss in the chat as well, which was when would I not use it? Yeah, that was Dirk's.
If you're fine tuning a model, you should just use Matryoshka loss, right? It's like it's all upside. As long as the maximum vector size is the size of the default, you know, vector size, let's say, like Matryoshka loss is just benefit all the way down, right? You might not need it. So for instance, if you only have like 10,000 documents, you know, you might not need Matryoshka loss. So from that perspective, you don't have to do it, but there's no like overhead or significant overhead, to be clear. There is some overhead, but there's no significant overhead during fine tuning that would ever make me say like you should not use it unless you're in an extraordinarily resource constrained environment. You know, it's like less than 10% additional compute to just have Matryoshka loss, and then it can save you literal petabytes of storage, depending on the scale of
Sounds
your
pretty good.
enterprise.
Rajesh, let's go to you.
Yeah, so Chris, what does it take to actually deploy it on Chainlit? I mean, you know, on Hugging Face rather. What is the missing piece that
Oh yeah, and I'll share my screen here. This is it. This is all you need. This is a Docker file. This is all you need. You already have this, so this has been provided. That's it. If you have this, as long as you've got that app.py, which again is just all the cells in the notebook copy and pasted with these two additional which again you have access to all of this. That's it. If you upload these files to Hugging Face with a Docker template space, it will run. Yep.
And I
Got it.
do believe this is a platform that you can like, if I wanted to go on LLM Wizard's profile and look at this, I could look at this, presumably.
Yeah, you just go to LLM Wizard and then you go to the midterm demo space.
And you can look at the files behind it, but don't tell
Yeah.
anybody. Oh, Josh. Okay.
Yeah.
Yeah.
Also,
Uh,
while pushing to
yeah.
Hugging Face, I faced a problem last time in homework 5 or something. There is a nice document written by, I think it's
Mike Dean.
Mike Dean. Please follow that document. I followed it by packaging it up with UV, and then all the dependencies got resolved. If you don't use UV, you'll just have the Hugging Face environment spinning, not showing any errors on screen. So if not for Mike, I wouldn't have been able to figure out. So please follow the document. Maybe it should be pasted again in the group announcements so that everybody can use it for pushing to Hugging Face.
Yeah, and this implementation does use the UV strategy. So if you're wondering what Praveen is talking about, don't worry about it too much. But there is a dope document that we will paste that was put together by Mike Dean that sorts out some WebSocket and UV issues with the deployment to Hugging Face.
Okay. I've got another question in the chat here. This is from Kariti. There's a bit of a discussion going on here. For SDG, why didn't we use our own fine-tuned embeddings?
So yes, I mean, it's interesting.
That is an interesting question. Yeah.
I would
Yeah.
say like it's a chicken and egg thing, right? So like we need SDG to fine tune the embeddings, and then we could use the fine tuned embeddings during the SDG, say like the Ragus SDG process. Yeah, you could do that. There's nothing stopping you. Yep.
Yeah, I mean, I thought like, I mean, we are testing the RAG pipeline on something that model never saw before it. So that's what I thought. Obviously, it's gonna degrade the results, right? So
I don't quite understand the question, but yes,
I mean,
you could
I mean,
use.
the question is, so the actual data distribution is something different, but already, but we are actually fine tuning our own embeddings, right? But
Yeah.
if you're generating the synthetic data without that same distribution, we are using some other distribution to generate the synthetic questions, and we are asking model to do better job on that. So I thought the distribution is different, so the evaluation may not perfect. That's what I thought.
There would, so the embeddings are not typically used very much in the actual SDG process. They're just used for Ragus. You can use them for the like some of the topic extraction. So there might be a small impact, but we would be happy to have no impact anyway, to be honest with you. So as
Got
in
it,
like
Chris.
that small negative noise is just going to help us test better. But yes, we can certainly create a test set that was easier for the model to get correct.
Got it, Chris. Chris, I have one more last question.
Yep.
So right now I'm working in a startup where we are actually implementing an AI kind of platform to our end customers. So it's purely like semiconductor domain. Say they don't know anything about machine learning and all this stuff. They purely drag and drop the widgets onto the screen to build any workflow. For example, hey, grab me the data from BigQuery. That's my first widget. And then perform this pre-processing. That's the second step. And maybe build some kind of a machine learning model. That's the third step. Actually, I want to deploy some kind of a chain link application out there where if user are specifying some query into that window, it should automatically provide the a skeleton of that workflow inside the app automatically. But the problem I'm seeing with Chainlint is it's unable to take any context from the main window. How to do it? I mean, is it the right approach even to go with?
It is, yes. So basically, like you're trying to provide some structured form or structured input to the Chainlet UI. Do I understand that correctly?
Yeah, for example, imagine something like this. You already have some web page which you already open. Imagine it's your platform web page. And some small pop-up came, it's the Chainlink application. Now you already inside some project of the application. Now you'll define your problem statement. Hey, I want you to
Yeah.
generate some kind of a skeleton. Then within this prompt, I want to capture which project that currently user is in and what is the user ID, something like that, some metadata from the main web application.
Yeah, I would probably Chainlet's not a great idea for that, to be honest with you. You might want to build like a custom React front end, which used to be something that I would never just suggest off the cuff, but a Cursor's great at it, so just get Cursor to help you with that. But the problem with Chainlet is that it's it is just a React front end. And in order for you to get the right like scope in terms of what can the front end, what does the user session see, quote unquote, on the page, right? I would just build a custom React front end. Rather
Got
than
it,
use
Chris.
Chainlet.
So
Yeah.
do I need to build the LangChain application, and then I need to expose that via the API, so the front end can integrate into their application, something like that.
Yeah.
Got it. Got it.
Yeah.
Thank you. That's all I have. Thank you so much.
Okay, Ashwin, do you have any questions?
Yeah. No,
yeah.
one question. Basically, with all this fine-tuning embedding models and stuff, right? One of the evaluator we used is like information retrieval evaluator, Chris. So it works great. My biggest confusion in the code is when I'm using RAGAS to do the SDG, the knowledge graph method, right?
Yep.
We want to do multi-hop and we get multi-hop information, a context kind of thing. How do we use that with information retrieval evaluator? Because that's only taking at one hop and multi-hop is multiple hops. So how do we use it? Do we use it? If yes, how?
I would say no, right? So like the Ragus embedding model information should not require, like the knowledge graph method should not require any specialized embedding model, right? Like a normal, whatever embedding model you pass into it should work. If you're doing like the unrolled version, right? Where we have kind of like each of the nodes being created. As far as like multi-hop and single hop, that should be handled by the Ragus library, and you shouldn't have to worry about your embedding pipeline at all.
No, I'm saying
As far
sorry.
as, go ahead.
Yeah.
Yep.
Well, I think when I'm generating data to fine tune, if I have
Yep.
a multi-hop data, would it be able to fine tune it or no?
Yeah. That's totally fine. Yes.
Or will we still be able to? Okay, that's what I was
Yeah.
not sure because looking at the document.
Each sample can have more than one context associated with it. Yeah.
Oh, okay.
Yeah. Just to be very clear, you will have to slightly alter the code that generates the IDs for the context. I believe right now, actually, it should just handle multiple contexts, but if it doesn't, you'll have to make the adjustment. Basically, each different chunk that's associated to the same question will need to share the ID, it will be part of the mapping of the IDs. So you will have to be careful to make sure that each question or query is mapped to the correct multiple contexts. But that'll be fine. Yeah.
Okay.
Yeah.
Thank you.
Yep.
Okay, we have 1 minute, so
Can I ask my question?
yeah, jump in. Yeah, okay. I was unclear if you guys still had more questions or, it's like, it's always hard to tell. What you got?
No problem. For me personally, right, my question regarding the prototype is, do we need to venture into the fine-tuning land, or could we show a prototype that is actually not very performant, meaning all the concepts, or because I'm not adept at writing loss functions or reward functions, I will fail on that aspect for sure because I'm not a coder by profession. So can I still go with this? Because you said it's engineering course, you want to see the idea, you want to see the design, you want to see the approach. Would you go light on the final output where the parameters of answering is not that efficient, but still you got the end-to-end idea
Well,
going?
let me tell you this, Praveen. Okay, so we've got to set up a very finite structure that's prescriptive, exactly prescriptive. But in reality, we want this to be as much like real life as possible. And so we want to see that you're working hard and you're trying to get after it and you're showing that you're putting in the effort and that you're somebody that we can like truly recommend and certify to, you know, everybody in our network and our hiring partners. And you know, like again, this is the midpoint, so it matters much more how you finish than how you're sort of like. So, you know, I would say like, you know, don't go around telling everybody that they don't have to do fine tuning. Okay. You know, but like work hard. You know what I mean?
All right, got it.
And then we'll take care of you if you take care of business. Okay.
Right.
And we're back, everybody. I want to go do a quick 5-minute break it out, shake it out. If you need a break, now's the time to take. And by the way, when we come back, you will, okay, meet new people. Okay. So splash some water on your face, get ready, turn the cameras on, okay, and get ready because you're about to meet some new folks. 5 minutes. See you back. We can keep rocking. Rajesh, do you still have something you want to ask? I'm going to go ahead and
Oh,
pause
sorry.
the
No.
recording here. Okay, and we are back from the break and we are ready to do a little bit of networking. But first, I want to remind you guys that, you know, really what we want to do here is we want to really structure the story and the thing that we're doing around something that's coherent, around something that somebody is going to care about. Like a real person is going to sit there and shake their head up and down like, yeah, that sounds like a real problem. That sounds like something that I would use. That sounds like something that could create real value in this world, something that AI could do some good with, okay? And that's where, you know, we want to think about, we have to have the problem, we have to have the audience, we have to have the proposed solution. There are other things we'll talk about later. We want metrics, we want data, we want, you know, at the end of the day, you will have to give a demo day presentation. And you got some feel for that today. Wiz had about 3 minutes of demo. So the demo in demo day is actually like mostly not the demo. It's mostly other stuff that you're telling the story. You're providing an intro, you're hooking the audience, and then you're bringing them with you onto this journey where you're solving the problem of the hero or the heroine in the story. And the solution that you provide is not going to be like a sort of technical detail. You're going to have this huge map of the app stack. It's just you're going to tell them about the solution. You're going to be able to answer questions about depth, and you're going to be able to go deep if you need to, but you really want to make sure that you're articulating these things quickly, succinctly, and on pointly, really. We want to do 1, 2, 3. And this is why we're going to give you about 3 minutes when we go and we start talking in breakout rooms in just a moment. When we do project pitches, I want you guys to think about the project you need to pitch. And just because you're not the pitcher in your group when it comes to demo day, it doesn't mean that you don't have to be a good pitcher. You have to sell yourself, even if it's just for a salary. It's just you don't get out of this. And this is our practice that we start today. So we've got a couple of great presentations we've seen in the past. We talked about Alan earlier. This is when Devin came out. Alan hit us with the Here Comes Kevin. This is from Robert Eubanks, if you're in the AI Executive Suite. His was pretty legendary as well. We talked about some of our favorite presentations in the session 3 sheet. Some of our favorite things we saw actually in enterprise over the last year, some of our favorite things that we saw throughout the cohort. We've got links that we encourage you to look at. Remember, I also shared that you guys can actually just use the little GPT we built to help you ideate. So what we want to do is we want to get into breakout rooms, and we're going to do this. We're going to do 2 rounds, and we're going to do 20 minutes each. So 20 minutes. What we're going to do is we're going to set you up with we're going to try to make it 4, maybe it'll be 3 new people that you have never met, or maybe just weren't in your journey group and they aren't your peer supporter. And we want you to spend 5 minutes each. Tell us about the problem, tell us about the audience, tell us about your potential solution. Each person gets 5 minutes. And what we're going to do is we're going to send a quick 15-minute warning, 10-minute warning, 5-minute warning, and we'll say 15-minute warning, switch, 10-minute warning, switch, 5-minute warning, switch. And we're going to do this twice today. So you're going to get to meet some new folks. You can try out different ideas. If you're playing with different ideas, you can try out different pitch schemes, and you can really also make sure that it's resonating with people. I want to see people nodding their heads. So turn your cameras on, everybody. We're about to get going. Also, finally, we've got a pitch presentation that we want you to sign up for. And we're going to drop that in the chat now. We've got 15 slots on Thursday where you're not going to pitch to 3 or 4 people. You're going to pitch to everybody. You can use slides or not, just like any old pitch day. But we want you to bring it, and we want you to tell us what you're going to pitch. I want you to secure your spot. You can secure it as early as you'd like. We'll throw it in the chat as we go ahead and open up breakout rooms right now. You'll see it in the chat when you get back. 20 minutes. Problem, audience, solution, times 4. 5-minute warnings. See how it goes. All right, so that was first breakout room. We're going into another one here in just a moment. But, I really want to just triple down on the point of the midterm. Some of you joined us today for Wiz's walkthrough. Some of you didn't. And the big thing about the walkthrough, Wiz, is that they already had all the code all along, right? There's no new code, and it's literally copy paste from all previous notebooks.
Yeah, that's exactly right. There's the 3 helper functions we talked about, but they're not in no way is like the core of the code or the functional part of the code novel. It's all just what we've been doing the whole time. It's literally extracted directly from the notebooks that we've already seen. And I think that's the takeaway is that you really are like plumbing it up, right? That's as simple as it can be. Obviously, if you want to go a little harder, of course,
right,
you're welcome to. But you certainly don't have to. You have all the boilerplate ready to rock.
Plumbing it up. That's what it's all about. Now, for you guys that are ready to go ahead and get your project pitches in, it is in the chat now. Open this up. Limited edition project pitch. Okay, this will be moderated by yours truly and will be judged by, of course, the Wiz. And then we want you to just write your little, basically this gets some of the midterm done before you leave the session. That's what it does, okay? So go ahead and sign up now. And then what I'd like to do is I'd like to go ahead and remind you guys that while you're working on this, we don't have Tuesday well covered apparently, but we do have a lot of stuff coming up over the rest of the week. If you wait until the weekend, you're going to have much less help. So go ahead and just jump into the Discord lounge anytime you see folks there. Feel free to work together. In fact, if you meet somebody right now and they want to have a little vibe sesh on the midterm, jump into the Discord lounge and do it with them at some point this week. Let's go ahead, breakout room 2, everybody. Try it again. Problem, audience, solution, new people. Let's go. All right, everybody, thank you so much for joining us today for the midterm introduction and the full end-to-end walkthrough. We hope you enjoyed meeting some new folks from the cohort. We hope to bring more of that goodness to you on Thursday, where we will play some AIM games at AI Makerspace, and Sarah will be our MC. It'll be very, very dope. We'll also do some project pitches, so sign up in the chat. If you're interested in learning more about how the midterm will be graded, we do have a grading rubric. However, I would highly recommend that you only focus on getting that GitHub repo with working code done in a way that you have the questions answered. That's going to be 80% of the work right there. That's going to probably get you as close to passing as anything. Although if you'd like a more complete breakdown, we're happy to share that with you, and we'll include it also on the midterm example page. Task 1, 10 points, task 2, 15 points, and so on. We will give you as much detail as you want. You can also follow up with grading at aimakerspace.io for more. Thank you for joining us again today. And there was the question in the chat from Dirk. Just use the pitch form to project pitch sign-up form. It is in the chat. We will be clear in the email we send out after class that this is different than the midterm submission. You can find the midterm submission form directly on the midterm page right at the top here, and it's called the Midterm Certification Challenge. We should probably start mixing up the little top bits a little bit here, but thank you for pointing that out, Dirk. We will clarify that in the follow-up emails today. So thank you again for joining us for session number 11 on midterm. Join us on Thursday for project pitches, AIM games, and more. Join us tomorrow live on YouTube, where we'll talk about reasoning in latent space, Coconut, and recurrent depth as an approach to help scale reasoning in latent space. See you there, or see you on Thursday, or see you in office hours, see you on Discord, see you on LinkedIn, and have a great couple of days. In the meantime, don't forget to build, ship, and share. Tell everybody what they can expect to see you build, ship, and share next Tuesday. And for Demo Day and Cohort 5, we'll see you guys on Thursday. Thanks for joining us. Session 11. Bye, everybody.
Bye, everyone. Take care. See you Thursday. Later.
Bye, guys.